Maybach music.
Can anybody out there hear me? Hear me? 'Cause I just
Welcome to our YouTube channel. It is called Studying Made Easy. Friends, you can access studying at any time, any moment, whether you're home or somewhere at work. You can understand any topic in any course unit that you've never understood. We're going to make it, and you shall be having different topics discussed on this very channel. Subscribe, like, and please, friends, make sure you share to others, even those people who are in different universities. We're going to discuss about digital logic. Digital logic, you know, this course unit, it is hard to some students, but we're going to make it for you easy via discussions that we shall be presenting or forwarding to the YouTube channel that you have. So friends, in the digital logic, we all know that is about numbering system or the number system of the digital world that you have. Okay, nowadays things are made easy. How? If you understand the number system in digital logic, you can come to understand that everything is easy. Because in case you know what the decimal means, the binary means, the octal means, and hexadecimal, you can come to understand that each and every decimal will be easy for you if you know the binary, and the hexadecimal will be easy for you if you know the octal. Now friends, defining number system, you may also define it as the number that represent or that is used to represent items and different things that appear in this world today. Now let's talk about electricity. You know, people, electricity, it is the only thing we have that if we don't have it in the world today, we can't perform our work. The electricity uses binary system. It uses 0 and 1. 0 and 1, we're going to understand it if we come to different number systems that we have in the world today. 0 and 1, this is a binary number system, whereby a 0 will represent off, and a 1 will represent on. Now, if your 1 represents on and a 0 represents off, that means our electricity that we're having today, it is represented by the binary system, a binary number system. Different things in the world today, they go on varying, or due to the fact that we're in a digital world, things are represented in different ways. But before going further, let's try to understand what do we mean by the term decimal. In decimal number system, we have only 10 elements or 10 numbers. Here in decimal, we shall have, let me erase this. In decimal, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, friends, in decimal number system, we have 10 numbering system or 10 digits presented in the decimal system. Now, here starting with the 0, it doesn't mean there that you have to end with a 10. No, because if you add the 1 and the 0, it will give us 10, which means we don't need to write a 10. It will be a combination of digits. Now, in binary, this binary means by. By is something like 2. Now, by, you all know that by means 2. And in binary system, we only have 2 digits. That will be 0 and a 1. You remember, by the time we are starting, I told you the electricity we're having today is represented in the binary system. And it is represented by 0 and 1, whereby 1 represent on and 0 represent off. If you see a 0 on your socket or your switch, it will be showing that the switch or the socket is off, and the 1 it will be showing that is on. Let's go to octo number system. The octo, friends, understanding octo, it is, octo figures. Octo figures have 8 sides. I think you all know that. Having them as 8 sides, in octo number system, we have only 8 elements or 8 digits represented in the octo number system. Now, in octo, we shall be having a 0, a 1, a 2, a 3, 4, 5, 6, 7. Now, you may ask yourself, why haven't I reached 8? But 8, being an octo number system, and they tell us that octo figures have 8 digits, or they have 8 sides, our octo number system will have 8 digits, which will start from 0 to 7. And if you count these digits, I'm sure you and me, you will come to understand that the digits will be 8, but not 7 as you're seeing them. Let's go to hexadecimal now. Something very funny with hexadecimal. This hexadecimal, it is the only challenging numbering system that we've seen like in class. But understanding it, you have to know that in hexadecimal, or a hexadecimal figure, it has 16 sides. Now, it having 16 sides, this means that our hexadecimal numbering system will have 16 digits. By them with 16, we shall start with a 0, a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9. Now, after reaching on 9, you will see that if you write 1 and 0, which will be a 10, you'll be repeating the same digit, the same decimal digits, but we don't need to repeat anything like a digit. Here, you're going to say that instead of writing a 10, I'll represent a 10 with a capital A, 11 with the capital B, 12 with the capital C, 13 with capital D, 14 with the capital E, and 15 with the capital F. If you count these digits, as you know that hexadecimal number system consists of 16 digits, you will see that these digits are going to be 16. From 0 to F, we shall have 16 digits, making a hexadecimal number system. Now, we have seen how all these numbering systems are represented in digits. We're going to see how can I apply them, like in calculations. You know, friends, different times you do find people fighting with the number. The number is just 1011. We have funny numbers that we are given, most especially during exams in the numbering system, because the numbering system sums up the digital logic as a course unit. Friends, if someone gives you a number, for example, 24, and it is 24, direct 24, not indicated, base 8, base 8, 24 base 16. This means that this 24, it will be a decimal number, because if we're writing decimal numbers, we don't give them the bases. For example, we may write 24, 9, 73, or 194. These are different decimal numbers. They will not be having digits. Now, here we might be having the binary numbers 0110, 1110, 1000. This is not a binary number. Why? it is not a binary number because it is not having its base. But making it a binary number, you will have to make it a base 2 to appear on the bottom of that number. The octal numbers, they will automatically run from 0 to 8. You have to be having 7, 6, 17, 14, but having bases, base 8, base 8, base 8. Then hexadecimal, it might be 9A. This will be something like, this will be represented by 9 and what? And 10. These are different numbers, but in writing them in hexadecimal, you don't write a 10, but you write a representative of that 10, where we saw that A represents 10, B represents 11, as we go on. So, they have given us a number here, 24, to calculate and to convert it. Okay, they may ask you that convert 24 into binary base. Now this number is base 10. Converting it to a binary base, this is a secret, friend. Why are you given a number that is in a bigger base? Are you turning it to a smaller base to divide? If you're given a number, I repeat this, if you're given a number that is in a bigger base, you're turning it to a smaller base, you divide that very number with the base that you're given. Thank you. Now, 24 we're turning it to base 2. This will divide that very number with the base you're given to turn it to 2. 24 by 2, you get 12, remainder 0. Here we have the divisor, the number, and the remainder. The divisor, the number, and the remainder. We go on dividing this number by the base we given to turn it to 2. Now by 2 we've seen it is 12, by 2, 6, remainder 0, by 2, 6, remainder 0, by 2, it is 3, remainder 0, by 2, it will be 1, remainder 1. Then here, by 2, it will be 0, remainder 1. Now, while writing the numbers that we have divided, we write from the bottom to the top. We shall have a 1, a 1, a 1, a 0, 0, 0, base 2. This will be our 24 in base 2. Now, let us see. If I am given a number in decimal, but I'm supposed to turn into base 8, how do I do that number? There are various ways that you can use, all different formats that you can use to calculate that number into the base that you're given. How? If you're given this number that is in base 10, you're turning it to base 2, to base 8, you can say, let me first change this number into a binary base, or let me divide it directly by 8, and I see whether the thing will work. Now, let us first use the first formula, or the simplest formula that each and every one can learn or can get and understand, that he can use in the paper. Remember, I told you this must be the divisor, the number, and the remainder. The divisor, the number, and the remainder. Take a note of this. The divisor, it is that base that you're turning to. Now, in case you want to turn this one to base 2, we saw that is 1, 1, 0, 0, 0. Now, if you have this 1, 1, 0, 0, and you want to check, remember, we have, okay, let's assume we have divided our 24 by 2, and we've got the answers 1, 1, 0, 0, 0 in base 2. And we're turning this base 2 into base 8. How do we do it? Now, changing this base 2 to base 8, remember our question.
Can anybody out there hear me? Hear me?